Fermilab, I'm quite disappointed with this intro.
It's summer, a
You
time
had
for
infinite world of
relaxation, some
choices.
fun at the beach, and intense quantum mechanics. What?
We had
Don't look at me like that.
2 out of 3 were definitely
Today I'm
negatives.
turning to my trusty beach balls to help explain one of
Work.
the weirdest
Your
ideas
time at
in
the
quantum
fucking beach
mechanics.
is not work. Picking somebody
Neutrino
up,
oscillation.
doing quantum mechanics at the
Put on
beach,
some
about the
sunscreen and
beach,
get ready. This
for the
is even
beach.
bananas.
The neutrino call come in, cling. How they oscillate, or
A quick refresher on
oscillations
neutrino
work,
oscillation.
waves,
This
doing the
odd
system. I get
behavior
it, it's
is
cute.
all about how neutrinos appear to change as they travel. So, an electron neutrino produced in the sun can arrive in a detector on
Do you
Earth
think really now is
as
the
a muon
vacation
neutrino.
time, guys?
If that neutrino doesn't interact in the detector and travels further, it can change into a tau neutrino. We've used this animation before to represent
Kind of like
oscillation.
a neutrino
It might even be how you imagine it
barium
happening at a
tritium
particle level.
at the virtual
The problem
level.
is that it's not quite right. I like to think of it in a different way.
Why don't they just put that on there
Imagine
anyways?
you have an
I mean,
incredibly
given
stylish
the reaction
pair
of
of
what comes
sunglasses
off of
that let
there,
you
it's
see
actually a
only a
neutrino. A
sliver
neutrino
of the
would be
world.
dark matter, wouldn't it?
And
That's what
someone
I'm
passes you a ball.
breaking
This
something
ball is
down
red.
into the smallest physical
You throw the ball
parts
to a
that
friend
are
who's also wearing
quantifiable
a pair of
given
special
the next
glasses.
step at least. Then you call that next step
no,
beyond that,
this
oh,
ball
that's
is
the
blue.
next dark matter.
Wait,
the-
what? You and your friend would be
Still
pretty
collision and
surprised
fusion.
until you realised you were looking at a beach ball with 3 different colours on it.
Vision.
This is similar to what happens with neutrinos. Imagine each colour on the beach
And
ball
then you get
represents a
X, Y, and
different
Z,
flavour.
M1 and M2,
Electron,
Mn,
muon,
and that gives me
tau
X, Y, and Z on the snowflake.
Neutrinos actually travel
Give me
as a
the
mixture of these
Axion,
3
the
different
Twister
flavours.
Theory games that I
And
need to
catching
do.
the
This
beach
being a
ball is
baseball,
like
but
when a
with 3
neutrino
parts
interacts in our
instead of 2.
detector,
And
producing
2
its
parts
partner particle,
are the same thing.
or
This
in
is
this
moving,
case,
this
appearing
is
like one
dragging.
single colour.
If there's anything
In
else
general,
that creates a
if a muon
field
is
inside of
produced in
that
the detector, we
of
say,
something
well,
little bitty,
that must have been
a
a muon
neutrino
neutrino.
or an
If we see
axion
an
or something,
electron, we
whatever.
infer an
It's like, and I
electron
catch that,
and
it
if we
drops
see
the
a
temperature
tau,
even
it was a
more.
tau
If I pull
neutrino.
out the temperature, no
So,
neutrino
our
shot
original
out of
animation
there.
doesn't quite work.
Totally
The
quantify the
neutrinos
system. That's
aren't
where I
literally
drop in the
changing into
M1 and
different
M2
particles.
MN
They're traveling as
comparatively
this
to the
weird
tau,
quantum
new
mix of all
neutrino, new
But our vision is limited,
anti-electron
and we
or
can only
whatever.
see them when they interact.
And so no matter what you do, you
choosing
ramp it
one
up,
particular
spin
flavour.
direction, then
Side
it's
note,
inflow.
I admit
So
my beach
inflow
ball
is the
analogy
first direction
isn't perfect
past the
either.
axis, but
When
on
a
full
neutrino
circle. I have
interacts,
to
it
ramp it up
fully
to full
commits
speed,
to that one
and if I
flavour.
get any speed
So,
differential
a
in
better
there,
analogy would
I
be
didn't
if the beach ball
quantify for
turned
something
into a
inside
solid
here
colour
for
when
the
I caught
EM
it.
fields of
If
that
you have this
distance,
advanced
not
beach
just
ball
the area of
technology, please contact me.
the Hadron Collider, but
One place the
also,
beach ball analogy works great though
a bunch of
is with this
factors into
idea
that.
of probability.
and
You
so
never know what colour you'll land
it's
on
if it
or
was
what
perfectly
neutrino flavour you'll
symmetry.
get.
That's
But
why
if
it
the red
has to be
section of
3.
your ball is really big,
It's
then
just
you have a greater
charge,
chance
how
of
much
seeing
charge,
red.
voltage,
And here's the thing, we
wattage,
can have
current,
beach balls with different
and you can
size
ramp up the
stripes.
voltage,
You can imagine all
ramp up
sorts
the
of different
wattage
combinations,
or the
but there are 3
amperage or
mixtures
the
that we're
work,
particularly interested
and
in.
say task
We call these
management is
the
what I need
mass
here
states
because
of the
yeah, I
neutrino.
could get
And
5
there are 3
guys
of
to
them.
do the job, but if I
Mass
get
state
10
1,
guys to do it, then I
mass
take
state
care of
2,
10 guys in a
and
crew.
mass state 1,000,000.
Don't smoke those
Just
guys
kidding, it's mass
and
state
spread
3.
it across the board.
We're so good
Of
at
course,
naming
they're going to
things.
get more power in the day,
This beach ball here
but at
is
the end of
actually
it,
the
not
right
give it to them
quantum
in the
mixture
paycheck.
for mass state
Are there
2.
different states?
There's a 1/3
Well, you
chance
pack
of seeing
enough in
each
there.
flavour, muon,
33
electron,
and a third
and tau,
makes
when it
66,
interacts.
6.
A very evenly balanced
And the
neutrino.
pie chart that I
My
generally
personal
go just off
favourite.
of vote. It's hard to make a move off of something that's not
A
at
mass
least
state 1 neutrino
66.6.
shows up 2/3 of the time as an
33% of the
electron
TV,
neutrino,
or
and
whoever
1/6
the
of
hell's
the
out
time
there.
as the other flavours.
And if it is
A mass
16
state 3
on those,
neutrino,
I'm
on
still
the other
getting
hand,
that. That'd be that kind of
almost
differential I
never
make a
shows up as
decision
an
on.
electron neutrino.
Well, the devil.
So now
well,
we know
think
that
about
there are
that
2
33
totally
left
valid
over.
ways to think about
Oh.
neutrinos. As flavour states, which
Not
is how
quite
we normally see them
50-50.
interact,
Or any kind of
and
weird
as mass
percentages on
states,
there
which
where
is
it's
how they like
still,
to travel.
that's,
As you might have
make it
guessed
easier,
from the name,
33
the mass
or
states
66
also
or any other percentage
have
inside of there.
mass. Here's the
The whole
mind-melting
matrix of
part.
pain
These
train.
flavour
High
states and
entropy and
mass
low
states
entropy is
don't
the
line
train.
up. So neutrino flavours, which is how we typically end up talking
Some
about
people like
neutrinos,
the train and
don't actually
Jean Grey
have a
superposition of
well-defined
matrix.
mass.
I'll change the speed. I'll
Asking
change how
what
many
is the
cars
mass of
it
an
has.
electron
I'll
neutrino
switch the conductor
is like
around.
asking, is a banana
Some
left-handed?
people are throw
It's
it
a
in the
property they
thresher,
just
melt
don't
it down,
have.
make it into
Only certain quantum
AR-15.
mixtures have definite masses. Those are our mass states. Quantum mechanics
I'm into
is
both.
weird, and it does not care
Which
how
one's in front of
counterintuitive
you?
this seems.
Sometimes you see a pile
It's
of metal,
a really
sometimes
hard
you see a
concept
pile
to
of
wrap your head
salties.
around. Each mass state can produce different
It's
flavours, the same way the beach ball is a mixture of 3 colours. And each flavour
Yeah,
is
particles
also a mixture
don't.
of the
But
mass states.
remember, without
After all,
the
if I think
people
I'm holding
in
a
the
red
room,
ball, I could still be looking at any
how
of the
would we
three
know what
beach balls.
happened?
I often get asked, if neutrinos are turning from one flavour into another, doesn't that mean they're changing
Changing field.
mass? Hopefully the beach ball analogy helps
That
explain
neutrino
that
click
they
you though.
aren't.
It's like, I gotta
The
hit this
neutrino
button right
itself
now.
isn't
Feeds and
changing,
speeds. Turn it
but
on.
the
Turn it off.
probability of seeing a particular
Between zeros
flavour
and ones and the
is.
percentages
It
there.
turns out that different masses were inside them all along. And so were the flavours.
100% Lucy Ultra Nightmare.
Okay,
Where your
we've
berry?
gone into a lot of detail about the flavour and the mass states, and I want to bring it all back home to oscillation. We know that, depending on the neutrino's energy and how far it's
I
travelled,
just use it as a training
we're more
aid.
likely
It's like,
to
what do you mean? I
detect certain
take the
flavours
smart
of
ones and I
neutrinos.
just
So,
destroy them
what's
on the
the deal?
first day. Oh,
Well, now
you
you
thought
know
you were
the
smart.
neutrinos are
Well,
travelling as a
go
mixture of
back.
mass states.
Go back off
And
Shangri-La.
because
Get
they
the
have
hell off
different
my mountain.
masses, they're all travelling at very slightly different speeds. The differences are so small that we actually can't measure them.
Sometimes you need something
But it
big like
does
that. It's like,
mean
no,
that
I'm
the
gonna take away
quantum
all the
mixture
manuals.
changes as a neutrino
Oh
travels.
no! See,
Essentially, the
you haven't
stripes on our
earned
beach
the
ball
manuals
are
yet.
growing
You
and
haven't.
shrinking
You got to
over
first
time.
foul
And that is
hard,
what
like
gives us the pattern
copper
that we see in
to
oscillation.
bullets to
When the mix changes, the chance of
AR-15-0-1.
capturing
You're
one
gonna
of
drop
our
your
quantum
ass out in the
beach
middle of the
balls
woods where
changes.
there isn't any
So the
copper.
probability of
Nothing.
seeing a particular
Give you
flavour
sticks.
changes. So all the
And you
quantum
come back.
weirdness boils down to this. The probability of detecting
a
any
hadron
given
collider,
neutrino
by math.
as any given flavour goes up and down
Control,
as
firstly.
the neutrino
It's
travels.
like, how big?
That's why we call it oscillation.
Math big,
And
because
that's
people are
how we end up
elements
with
and
detectors
they
at
have
different
limits on
distances,
averages
seeing
of
different
hydrogen,
neutrino flavours.
composition, color,
Scientists
what I
designing
didn't
experiments
purify
to
on it,
study
soldier.
oscillation can work backwards to figure out the best location for their neutrino detectors. That is, the spot where they'll see the most neutrinos changing flavour. Once you know how much energy you'll have in your neutrino beam, you can figure out how long you want it to travel for. A bit of maths, and you can basically
I
draw
like
a circle
Snowball.
around the starting point
Or I
with
like
the right
Snowball,
distance.
Snowflake, and Buttercup.
Find a mine
like
to
the
shield
rest
your
of them.
experiment from cosmic rays.
You want to
You're
win a
ready
race,
for some
Marshmallow?
neutrino
Go
physics.
hop the dragon and get
If
on
these
there.
concepts are a lot to
Yeah,
take
no,
in,
it sounds like
you
a
are
horse.
not
It's
alone.
definitely a
A
dragon.
common saying among physicists is if you
You
think
sure?
you understand quantum mechanics, you don't.
It's got
Do you
a
have a
ring
different
right here.
analogy for thinking about neutrinos?
Sarah.
Do you hate beach balls now? We love to hear from you, so let us know in the comments.
Catch you on the next one.